Deloused, jugga jiggy wugga, daily style, jugga jiggy wugga.
Okay, so we're looking at the C1 problems from Unit 3. These are non-uniform motions. So what we have is a car traveling due north at 20.7 meters per second. We're looking for the velocity of the car after 7.5 seconds if the acceleration is, well, 1.6 meters per second due north, and then for part B, 1.95 meters per second squared due south. So let's just draw a quick little picture here. Here's a car. Sure it is. And it's traveling due north at some initial velocity of 20.7 meters per second. Now, we also know in part A, it is accelerating at 1.6 meters per second squared, also due north. And if we're calling 20.7 positive, then what we're really talking about is saying that north is our positive direction here. Okay, so this acceleration will be positive. And it's traveling for a time of 7.5 seconds. So if we're looking for a final velocity here, VF, we can go ahead and actually use equation number 3 here from our best friend, which states that VF is equal to VI plus the acceleration multiplied by a time. Now that we have an equation here, we can just put in some numbers, which is really nice for us. We can say that we know our initial velocity, that is 20.7 meters per second, plus the acceleration of 1.6 meters per second squared. And this is nice because when we multiply it by a time of 7.5 seconds, a second is going to cancel out, and we're going to get meters per second plus meters per second, which is what we need. It will give us a final velocity, and we will find that number to be, but let's figure it out. So 7.5 times 1.6 is 12. 12 plus 20.7 is 32.7. So we get 32.7 meters per second for part A. Now, if we go ahead and we take a look at part B, it's a very similar problem, but only our acceleration has changed here. We're no longer accelerating to the north. Our acceleration is equal to 1.95, there's a bell, south. And since we called north our positive direction before, this implies that south is the negative direction, so we're going to have to throw in a negative in front of this. In the end, it's going to be the same equation, VF equals VI plus AT, number 3, but this time we're going to have VF equals VI, the 20.7 meters per second, plus negative 1.95 meters per second squared for the acceleration, multiplied by 7.5. And we need to make sure that this negative goes in there. We're going south with this acceleration this time. It's a negative value. So if we go ahead and multiply all this together, 7.5 times negative 1.95 gives us negative 14.6 something, plus 20.7 gives us a final value here for our velocity of, let's say, 6.08 meters per second. Okay, so very similar equation, but we had to be sure that we had a negative value there for the acceleration because it was pointing in an opposite direction. But with that, it wasn't a bad problem. We simply draw a picture, identify our variables, pick an equation, in this case it was number 3, and then plug in values and solve accordingly. Okay, so with that, this problem is finished. Adios, and take it easy.